Welcome all of you to Animaths. Now in this video we are going to take up square roots. Like in the last video we had done squares of a number. So we are in the chapter squares and square roots. Okay, so this video we shall be doing square roots of numbers. We shall be taking up prime factorization and few problem sums for doing square roots. Okay, we might even take up square roots of a fractional number. Like in the last video we had taken up square roots of squares of a particular number, of a decimal or even a fraction. So today we are going to take up square roots of a fractional number or square of a number by the method of prime factorization or few problem sums. Let's see. Okay, so here we have, now what is square roots exactly? What exactly is square roots? Square roots is if I have the number 4, okay, and I am asked to find the square root of this number, then square root of this is that number which was multiplied with itself to give you this number. Okay, so now we know that the square root and the sign of square root is this, okay, and we know that the square root of this is, okay, so the square root of it is 2, not 2 into 2. Okay, so 2 into 2 is equal to 4. Therefore, square root of 4 is a 2. Similarly, for 9, square root of 9 is a 3 because 3 into 3 has given me a 9. Okay, then if I take square root of 25, that is a 5. Similarly, square root of 16 is a 4, like this. Okay, so this is what we call by square roots. Now don't write the number 2 here, that's not required. Only this sign tells us square root. So if you put x here, it means square root of x. Okay, so let's see square root by prime factorization. How do we do that? Square roots by prime factorization method. Now we'll take up a number which is, let's say, 441. I'll take up a very simple number first, 441, and we shall be finding the square root of this number. So here I have to keep the test of divisibilities in mind all the time. Now here it is definitely not going by 2. Now this is prime factorization method, just like you had done for LCM. This is taking out, for LCM you had done for 2 or 3 numbers together. Here I shall be doing for individual numbers. So here I can see one thing from the test of divisibility, that it is going by 3. 4 plus 4, 8 plus 1, 9. So it goes by 3. So I am going to take up 3 here. It's not going by 2, I saw. So when I take 3 here, 3 ones are 3, okay, then 14, 3 fours are 12 and 7. Back again I am adding, this is 11 plus 1, 12, it goes by 3. 3 fours are 12 and 3 nines are, and then 7 and 7. Okay, now I have to observe this. I have to keep observing this, the factors. So 441 is equal to 3 into 3 into 7 into 7. Now be very careful. Don't put the sign here and then write all the factors. When I put the sign here, when I put the sign here, then I am going to choose just one out of every pair. So 1 3 from this pair of 3 and 1 7 from the pair of 7. That gives me a 21. So 21 is the square root of 441. In other words, if you multiply 21 with 21, you are going to get a 441. So this is the method of prime factorization. Where now, why this name prime factorization? We name it prime factorization because, see, all these numbers that we get here are supposed to be prime factors. This number was also going by 9, but why I didn't take 9 is because 9 itself is a composite number. I cannot take any composite numbers in this method. If I take 9 here, 9 will be hiding 2 3s. It will be hiding factors. Composite numbers hide factors in it, and so I will not be able to get the correct pairs. That is why this is always only for prime numbers. Okay, let us see another example. Let's take 2304. Okay, prime factorization of this. Now I can say it's going by 2. So first let's take it by 2. Okay, 11. Okay, I'm dividing it here straight. Don't try to divide it in rough. It is going to take up a lot of time. Then 5. Okay, because this is 22, 1 here, 10 and 2. This is 2, 5 and 1, 7 and with 7, 14 and 6. And then, okay, let me take I can take a, can I take a 3? Let's see. It is going by, let's take a 2 only. 2 2s are 4. 2 2s are 4 and then 17, 4, 2 8s are 16 and 8. And then 2, 1, 4, 4. Okay. And then I will further continue. 2, this is 7, this is 2. And then let me continue here. 72, this is back again 2, 36. See how many 2's I am getting. Then 18 and 2, 9 and 3 and 3. Now what you have to check here is, are the 2's coming in pairs or not? Okay, 1 here and 1. These two make a pair, 1 pair, and see, everything has come in pairs. So more or less I can assume that the sum is going correct. Now what to do? Here I shall be writing cube root of 2304, and that is 1 2 from this pair, 1 2 from this pair, 1 2 from here, 1 2 from here, and 1 3 from here. Okay, that gives me 4 into 4 into 3, that is 16 into 3, that is 48. Okay, so this is my final answer. So 48 is the square root of 2304. Now here I have to quickly do one small checking. 8 into 8 is a 64. That means last digit is a 4. So here also last digit is a 4. So even if I haven't checked the complete answer, I have more or less an idea that yes, my answer is correct. Okay, let me take up another sum where I shall be doing once again prime factorization only. Okay, that is, let's take, okay, 1764. It definitely goes by 2. So 2 8s are 16, 8, and then 2 2 4 4 1. Then it goes by 3 1s are 3, and then 3 4s are 12, 3 7. Okay, 3 4s are 12, and 3 9s are, and 7 and 7. So clearly I have got all pairs. So square root of 1764 is equal to, so when you put the sign, then only you are going to pick up the pairs. If you don't put the sign, you have to write all the numbers, all the prime factors. But if you put the sign, you are going to pick up the one from the pairs and write. Okay, that is 6 into 7, and that is a 42. Okay, so here also I am doing a small check. 2 into 2, 42 into 42, last digit is going to be a 4. Here also last digit is a 4. Okay, now so that was prime factorization. Now I want to quickly take up one question where there will be a fractional number. Okay, and we shall be finding the square root of a fractional number. Let's see what I am talking about. So if I see a fractional number, sometimes people get very confused with this. They leave this sum in the exam and come, but it is such an easy thing. So here I have this. Okay, so if you have this, I have to find the square root of this. So let me put the sign also. Okay, so if you don't know the square root of this, let me find it. So it is 2 7 2, yeah, 2 3 6, 2 and 18 and 2 and 9 and 3 and 3. So here I have 2 into how many 2's? 1 2 3 4. 4 2's and 2 3's. And below that, for the 225, I have 225. This is with a 5. Okay, 5 4's are, and then 5 5's are 25. 5 9 and a 3 and a 3. This is 5 into 5 into 3 into 3. Okay, now cut this. Now see, I have just prime factorized, and since I have not written it outside the sign, I have written all the factors. Okay, so I am cutting the 3 with the 3 because they are all in multiplication. Now here I am left with 2 pairs of 2. When I take it out of the sign, I will have to write, this is, remember this I had written only in place of 144, so I have to write all the numbers. Okay, but when I write the square root of this, I have to pick up one from the pair. So 1 from this pair and 1 from this pair. Here 1 from the 5. That gives me a 4 by 5. Okay. So this was square root of a fractional number. Otherwise also, supposing you know the squares, you know the square roots properly, I could have written this and it's going to give me the same answer. So if you are doing it as a rough work or as a part of a sum, you can always do this. Cancel with a 3 and you get a 4 and 5. Answer is 4 by 5. So whichever method, either this method or this method, depending on your requirement, you can always do. Okay, so let's take up another number. These are the numbers, these are the sums which you generally leave out. This is a very simple question. Here, it says the square root of, we have to find the square root of 0.000676. Okay, 0.000676, this is a 0, okay. Then how do we find this? Now the moment we look at this sum, we feel we have to work in some decimal method. Actually, this is not a decimal method. What we have to do is, the easiest way is this. We write 676 and we divide it by 1, 2, 3, 4, 5, 6 zeros. 6 zeros. Okay, so we have divided it with 6 zeros. So now we have to find the square root of this number. Okay, so let me put the sign here also and the sign here also. Now it is easy to find the square root of this kind of a number where there are only ones and zeros. If there are 6 zeros, the square root is 1000. That is just half of the number of zeros. Okay, now how to do this? 676. 676 will have to again go for a prime factorization method. 2, 3, okay, 6 and then 2 and then, okay. So clearly I can see that there is the square root of this is a 23 because 1 2 from here and 1 13 from here. So here if I write 26, okay, 13 into 2, that is a 26. And once we have written the 26, below we are going to find the square root. We don't have to work for this, only this. So our answer is 0.026, that's all. Okay, we have divided 26 by this and given a decimal answer only. So this way you can find the square root of this kind of a decimal number. Okay, now let me take up few very important questions in this chapter. Very important. They are always asked in exams and they really help you to understand the chapter better. That is, now the question goes like this. Find the smallest natural number by which the given number should be multiplied to get a perfect square. So we are going to take up the number 3703. 3703. Now this is the number given to us and we are asked, as you can see in the question, find the smallest number which should be multiplied with this number to give it a perfect square. Okay, now the first thing that we notice here is, so this is not a perfect square, we have to make it a perfect square. Now here we note that it's not going by 2. So what to do? So next we do is 3703. So we can actually think of this is let's try with a 7. This is not even going with 3. Okay, it's not even going with 3 because I checked with 3, test of divisibility of 3. But then I am checking it with 7 and it is going by 7. 7 5s are 35. Okay, 7 5s are 35 and then 7 2s are 14 and 9. Okay, then it is 23 and a 23. Okay. So now then we have done prime factorization, but what we can see here is we have not we can't get square root of this. That itself shows this 7 does not have a pair. That itself shows this is not a perfect square. Now the question did not tell us to find the square root. The question told us to find that number which when multiplied with this number makes it a perfect square. Now don't you think that here if I multiply this number with another 7, then when I do the prime factorization, it will get another 7 in the prime factors. Okay, because I have multiplied it with a 7. So here, because this 7 did not have a factor, we can, a pair, sorry, not a factor. So 3703 has to be multiplied by a 7 to make it a perfect square. Okay, so that is our answer. That's our answer. Okay, so 3703, if we multiply with the further with the 7, this 7 will get a pair, and so it has to be multiplied by a 7 to make it a perfect square. Now here I want to tell you there will be questions of another type, which is find the smallest number by which it has to be divided to make it a perfect square. Okay, now these are two types of sum. This one we were doing what has to be multiplied. The next one that I am going to take up is what has to be divided. Okay, what has to be divided to make it a perfect square. And I want to tell you these two types of sums are supposed to be done only by prime factorization method. Okay, they are not supposed to be attempted by the division method of square root. Why I am telling you this is you should not get the idea that we can anyhow attempt it and get the sum right. Okay, so we have to do it only by prime factorization. Only then we can get our answers easily. Okay, so now let us take a sum where we'll take what has to be divided with. Now, so here the number is 245. We can see it is clearly not, we can clearly see this is not divisible by 2. So we'll start with a 5. 5 3s are 15. Okay, 15 and 12. 5 2s are 10. 5 4s are 20. Okay, and 5 9s are. Now here we have a number which is not going to go by 5 again, neither by 2. So let me try with a 3. I can see it is going by a 3 because if I add all this, okay, this is 5, 5 plus 4, 9, 9 plus 9, 18. 18 is divisible by 3. So by the test of divisibility, we know that this is going by 3. So we can start dividing with a 3. This is 0 because in 3 it didn't go, then 8. 3 8s are 24. We have taken this full thing and 3. And now again what do we divide with? Let's check for the divisibility of 3 once again. It's a 9 plus 3, 12. 12 is again divisible by 3, so we can start with a 3. This is 6 and 1. Now 361 we know is the square of 19. Okay, so 19 is the square root of 361. So we have taken up 19 here. So it will not go by any other factors. 19 is a prime number, it will go only by 19. So now if you observe this, we see this has a pair, this also has a pair, but this does not have a pair. So don't you think if I divide this number with a 5, okay, because these are all the factors, if you divide it with a 5, then this number will become a perfect square, because what will be left is pairs of numbers. I can do it and show you here. Let's take 1625. 16245. in place of 16245, if I am writing, I can write 5 into 3 into 3 into 19 into 19. Okay, into 19. If I write this just in place of this, because these are the factors. Now if I divide it with a 5, note, I am left with only pairs of factors. Okay, with pairs. So I need full pairs. Only if I have full pairs, I can say it is a perfect square. So the number that is now made up with this 361 and the 9, okay, this number, whatever it is, whatever it comes to, is a perfect square. So the one which did not get a pair, you have to divide the number with that number, and you have to divide the big number with that number to make it a perfect square. That is the answer. So the number 16245 has to be divided by 5 to make it a perfect square. Has to be divided by a 5 to make it a perfect square. The number 16245 has to be divided by a 5 to make it a perfect square. So be it this sum or be it the previous sum where we had what has to be multiplied to make it a perfect square, we always have to look for the number which didn't get a pair. Okay, we have to look for that number which didn't get a pair, and to make it a perfect square, you have to either divide by that number or multiply by that number and give it a pair. Okay, so that is it for today in squares and square roots. Okay, so we will not be proceeding further in today's video. After this, we shall be taking up more problem sums in the next video. There will be lots of problem sums are there in square roots. So our next video will be made up of only problem sums. Okay, and then I need to tell you about the division method of finding square roots too. Okay, please watch the videos in a serial order, as I have always told you. Please watch them serially so that you can understand the topic better. That's it for today. Okay then, if you have liked the video, do not forget to like, share and subscribe. Thanks all of you.